Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. Today's video, we're going to be looking at the homework solution for TopTechBoy's Raspberry Pi Pico series, lessons 20 and 21. In these lessons, we were instructed to take the DHT11 temperature and humidity sensor and interface it with our Pico and utilize a push button to change modes between Celsius and Fahrenheit. And so let's take a look at our setup. First thing I want to point out is that I've moved my wiring from the standard Pico back to the Pico W. Coming up in future lessons, we're going to be doing more kind of portability type stuff, so I wanted to make sure that I was back on the Pico W when we get to the wireless portion. And in terms of peripherals, I'm pretty standard here. I've still got my RGB LED. We're going to use that in today's lesson. I've got the DHT11 wired up with the single signal pin going to the Pico. And then I have two push buttons, a red and a green. Neither of these are using the pull-up resistors because I've got those pulled up in code. So let's take a look at our program, and I've already got it running here. And we're reading the temperature and humidity of the DHT11. Now, if I just put my finger on this, it's going to warm it up. And we'll see first the humidity climb up, followed by the temperature. And while I'm doing that, I'm going to switch scales from Celsius to Fahrenheit. And you can see we're increasing in temperature and humidity. And then as I take my finger off, it's going to drop down. I did hope to use the ice pack in this video so I could raise the temperature and then dramatically lower it. Unfortunately, that just wasn't working out, so I had to skip that for this video. So that is lesson 20. Now, before I go through the code, I want to show lesson 21 because they are related. Basically, 21 is just an extension of 20. Our instruction was basically do something different with the buttons. And I'm at the bottom of the code where I don't want to be. All right, and so we're going to start it up, and we can see the LED goes red, and the reason is because of our changing temperature. So I wanted to represent changing temperatures not just with text on the screen, but also through the LED. And I did a little bit of basic math. I'll show you kind of my scribbles here of how I did this. So I just kind of defined some temperatures. Beyond 27C, we're going to be full red. In between, we're going to be a mix of green and red with a peak. I think it's around 20 or 21C is kind of optimal green, so that's full green. And then as we cool off, we get a little less green. We start to bring in the blue. And by the time we get to 8 Celsius, which is pretty cool, we're full on blue. That was the goal anyway. Again, didn't have a chance to get the ice pack situated and working the way I wanted to. But now you can see I'm grabbing onto my sensor again with my hand, and we're going to increase here. And we're going to go a little more red, and once we hit, I think it's 80 degrees Fahrenheit, we're going to see full red. Now, again, I'm using the red button to change my temperature scale. So you saw me change from Celsius to Fahrenheit. And now if I press it again, I change from Fahrenheit to Kelvin. And if I press it again, I switch from Kelvin to Rankine. Now, if you're not familiar with Rankine, think of how the Celsius scale is really a subscale of Kelvin. It's the same slope. If you think of slope-intercept formula, Celsius and Kelvin have the same slope, just different y-intercepts. Whereas Celsius starts at the freezing point of water, Kelvin starts at absolute zero. The Rankine scale is very similar, but with Fahrenheit. So it's the same slope as Fahrenheit. However, the y-intercept is, again, absolute zero in Rankine. So I thought it would be fun if we're going to add some scales. Let's add Kelvin and Rankine to our Celsius and Fahrenheit scales. And then if I press it again, we just kind of come around. But of course, you've noticed there's a green button, which obviously does something as well. Let's see what that does. Actually, I'm going to flip this to the Fahrenheit scale. There we go. And now I'm going to press the green button. And you can see we've changed from reading the humidity of the sensor to calculating the dew point. The dew point is a measure of how much water is in the air based on relative humidity and temperature, taking both into account and coming up with a new value. The dew point can never be higher than the ambient temperature. And here we see our dew point is mid 50s while the temperature is close to 80 degrees Fahrenheit. And again, if I put my finger on this, we're going to see the dew point climb first, followed by the temperature in Fahrenheit. All right, so that's all fun and good. I'm going to stop this program here, and I'm actually going to do this to reset it. Bear with me. Okay, so let's take a look at the code for both of these programs. So we start off with pretty straightforward stuff. We're just importing our libraries, setting up our pin values. In this lesson, even though I didn't use the LED, I brought in the LED code because I wanted to be able to reset the LED to 0, basically for demonstration purposes. So though not necessary to the running of the program, I do have it clearing out the LED status and then reading the input from the pin. And I have a list set up of my temperature units, one item for Celsius, one item for Fahrenheit. And then I'm setting my index of 0 by default. Then I'm going to read in the sensor data, or define the pin for the sensor data, sorry. We're just defining it here, we're not actually reading it yet. Now we're going into our while loop, and we're going to read the value of the push button, and we're going to read the value of the temperature sensor. As you've seen before, I'll go into an if statement of, if I'm not pressing this button, the value is true. So if it's false, that obviously means I need to take action. The button's being held down. I go into this while loop. So while it's being held down, nothing is happening. And then when I release the button, I am going to change the index of my temp units list. Now I want to point this out because there was some discussion about this in one of the classes about using modulus to decide is it 0 or 1. And Paul made the point that if you do that, you can actually run yourself out of space in the integer. I can't remember what the upper value of an integer is, but you can actually exceed that and crash the program. So the way I've gotten around that is I'm taking the current index and adding 1. So if the index is 0, it becomes 1. If the index is 1, it becomes 2. Then I'm taking the modulus of the length of my list. So in this case, I have 2 items in the list. So if I take 0 plus 1, I get 1. Modulus 2, I get 1. And then I'm writing that back to the index. So the index can only be 0 or 1, because if this is 1 and I come through here, 1 plus 1 is 2, modulus 2 is 0, I now write that as the index. My index value is only 0 and 1. I don't have to worry about overrunning the integer value. And then I just have some simple if statements here as to what am I calculating, Celsius or Fahrenheit. If I'm Celsius, I don't have to do any calculation. Fahrenheit, I'm going to do our good old 9/5 plus 32 and print it out to the screen, and then we just loop around. I should point out this sleep statement, 300 milliseconds seems to be the best value to use for the DHT11. I tried 200 milliseconds and my program would occasionally crash. These things will crash your program if you try to read them too fast, and I found, for my sensor at least, 300 milliseconds was kind of the winning value there. If I tried to shorten it any more than that, I would get a program crash. All right, so now let's take a look at lesson 21, which is obviously more complicated. So here I'm setting up my pins for everything, including my LEDs, of course. I'm setting up PWM objects for each of the 3 colors, and then zeroing them out with frequency and duty cycle. There is a more efficient way to do this using dictionaries, but I couldn't remember what it was, and I was trying to just get this lesson done. So I kind of punted and did it the slow, boring way, but I know there's a more elegant way to do it. And then I'm setting up my input pins for the red and green buttons as well. Now here's where I've got my temp units list. Instead of 2 items, just Celsius and Fahrenheit, I have added Kelvin and Rankine. So we're going to see that again as we go down, moving that index from one to another. And I'll point that out when we get there. Humidity units, we toggle between humidity and dew point. Real handy piece of information, humidity and dew point contain the same amount of characters. Really helps when print formatting, saves me a step. And then I'm just kind of going through zeroing everything out, setting up my sensor pin, and now I'm heading into my loop. And each time through, I'm reading the state of both buttons. I'm reading the state of the humidity temperature sensor. And each button, I'm basically doing the same kind of loop. So I do my if while loop for the red button. And here I have exactly the same code to move my index. So in this case, because the length of my temp units list has gone from 2 to 4, I just changed the modulus value. So now 0 becomes 1, modulus 4 is 1. 1 plus 1, 2, modulus 4 becomes 2, and so on and so forth. When we get to 3, 3 plus 1, 4, modulus 4 is 0, so we loop back around. So again, our index can only be 0, 1, 2, or 3. We don't have to worry about that incrementing. And we do exactly the same thing with the humidity button, mode change button, moving that index again for the humidity units. Then we have to do all the math, and yeah, there's a lot of math. So I'm coming in and basically looking each individual temperature unit I'm going to treat as an individual case. So I've got Celsius. Now, of course, I'm just reading the sensor data in, but I need to do some conversion to get to dew point. Fahrenheit, even more so, because I have to calculate the temperature in Fahrenheit, and I have to take that value and then calculate the dew point at that particular temperature scale. Now, Kelvin and Rankine get interesting because I calculate my temp value, but then I have to reduce my temp value by the same amount before I calculate the dew point, and then I have to add it back in. Made that mistake, and I was getting some astronomical numbers for my dew point, so I knew that wasn't right. And then Rankine doing exactly the same. So what you see here is regardless of which dew point or humidity mode I'm in, I'm always calculating the dew point. If I'm in the humidity mode, oh, and then I'm creating the text string output. But if I'm in the humidity mode, I'm just going to overwrite that with what the sensor value is. And in both cases, I'm putting it into a pre-formatted string. So that way we come down here into our print statement, and I don't have to do any special formatting here because all that formatting was already done through the math segment. And then when it comes to lighting the LED, we're just doing these temperature scales that I predefined. I could have gotten a little more elegant, I think, and done a little more math. But honestly, I just wanted to punt and get it done. And so that's why here, I'll put this up again. I just kind of came up with some arbitrary numbers for what do I think is red, what do I think is green, what do I think is blue, and kind of define some crossover points. The slopes are all different, the intercepts are all different, so I didn't want to get too advanced with the math. And then just doing a simple write it out using the PWM objects in a dictionary. And then we're back to that 300 millisecond sleep loop before we come around to make sure we don't crash the program in reading. And so that might have seemed like a lot, but I thought I'd really have fun. We had some license to really do some fun things in lesson 21. So I wanted to take advantage and use what I already had on my board, as well as just kind of seeing how far I could push the limits of things. So looking forward to the next lesson as well. If you like this video, be sure to hit like and subscribe below, leave a comment, and I will see you next time. For Simply Brian Enterprises, this is Brian, and thank you for watching.